theorem, take one. Okay? Pythagorean. Man, boy, I'm writing pretty well up here. And the Pythagorean theorem says that a squared plus b squared equals c squared, a squared plus b squared equals c squared, where a and b are called the legs, okay? And c is called the hypotenuse, and it's only for hypotenuse. And it's only for right triangles. Only. Okay, so if I have a triangle, I have to try to draw a triangle. This one, boom, boom, boom. Is that going to make a right triangle? Yeah. Okay. And say I know that this side is 3, and this side is 4, and that this is a right angle. You need to know that, and you want to know that side. How do I set that up? Yes, Eric.
Well, you're going to do 3 squared.
Yes.
Plus 4 squared.
Ah,
Yeah. Equals c squared.
equals c squared. And then what?
What are you going
9
to do?
plus 16.
9
9 plus 16 equals
c squared.
c squared.
Which equals 25.
25 equals c squared.
That's 5.
And then what?
Square root of 25.
So you take the square root of 25, and that's equal to c. So c equals the square root of 25, so c equals 5. Questions about that? And when it comes out where these are all nice, neat numbers like that, that's called the Pythagorean triple. Okay? Pythagorean triple, when they all come out nice and neat. Triple, all sides are integers, whole numbers, whole positive integers. Positive, you can have it positive integers. Okay, so let's do another one just for practice, easy. Let's do another piece of paper. Let's do this one.
Mr. Leader, these are the conjectures, right? I didn't get
Yeah.
one. All right.
Say this is, hey, it didn't work. Well, you get the idea. Oh, there is it. I can't. Say this side is 13, and this side is 5. And I say, fine, we'll call this side B. Go ahead, you try. You try. So in this case, you have to be a little bit careful because this is not the hypotenuse. So you have to set it up as b squared equals 5, whoops, that's wrong, as b squared plus 5 squared equals 13 squared. Why is this thing being moved? 13 squared. And so you squeeze that as b squared. 5 squared is 25. 13 squared is 169. Now you have to subtract the 25. Is that what you did, Max? Okay. And you get b squared equals 144. So b is the square root of 144, which he found out is 12. Okay? So this is another example of a Pythagorean triple, right? A 5, 12, 13. After you've been teaching math for a long time, you get to recognize, oh, this is a triple. And there aren't that many of them, but anything that is a multiple of a triple, so if you know that 3, 4, and 5 is a triple, and 5, 12, 13 is a triple, then anything that is a multiple of those will also be a triple. So say I took those numbers and I multiplied everything by 2. So 6, 8, 10 would also work in the Pythagorean theorem, okay? As would if I multiplied this by 3, and I got 15, 36, 39. 15 plus 36, 15 squared plus 36 squared would equal 39 squared, okay? And those are called triples, okay? Let's do one that doesn't come out to be a nice even number, okay? So, for example,
Participation point.
right?
Participation point for this one too.
Participation point. Oh, that's doing the wrong. That's not going to make it into. Hey, I used the wrong tool. Gotta reuse the right tools. There we go. So again, G. Knowing this is a. So let's say that this side is 9, and this side is 7, and this side is, we'll call this C over here, okay? And they say find C to the nearest 10th. To nearest
12.25.
10. Wait, slow down there. Raise your hand. Maggie's turn.
What?
11.4.
11.4, is that right? 81 plus 49. What's that? 130? Is that 130?
Yeah.
130. So you take the square root of 130. And is that 11.1?
11.4.
11.4. Okay. So very good. That's easy, right? Now, sometimes they will say leave your answer as an exact answer. And when they say leave it as an exact, you leave it just as the square root of 130, okay? Because this is exact, this is rounded up. Question so far? Next thing that you're going to see is, and this is the thing that gets people a bit confused, is they will have a circle. Where's that tool that does the circles? Just plain old circles. Oh, well, we'll try to do it with this thing. Can I draw a circle? Let's see that. That'll work. Okay.
That'll work.
And say I have, so this you'll find out when you take trigonometry. This they call a unit circle. Well, actually, this isn't a unit circle. But say this is the XY axis over here. And they put a point, you'll have a homework problem like this. They'll have a radius going up to this point, and they'll call this 3, 4. And they'll say, what's the radius? What's R? Kind of an application of the Pythagorean theorem. What's R? So, anyone have any ideas? How would I figure that out?
No idea.
Well, yes, Matt, it's 5. And Matt's correct. He's going to get a point because I don't want arrows. If I were to drop a line straight down here, okay, so this is the point, this goes over 3, right, and up 4, over 3, and up 4, so if you did the Pythagorean theorem or you recognize that it's a triple, R equals 5. So you'll have a couple problems just like that. The other kind of problem that, one of my favorite problems, and one you might see, not only on it, you will see on a test, but also they like to give you these kinds of problems on standardized tests, is if you have a box, okay? Box? Will that make a box? It did, okay? And then on that box, oh, it's a different color box, that's okay. No whistling, please. Who's that? You're tied. There must be a better way to make a box, but that's okay. Let's just say that this is a box, and its dimensions are 8 by 6, okay? And that this is 5 over here, okay? And what they're going to say to you is find the longest stick that can fit inside this box. So in other words, you want to figure out if I were to take a stick and put it in this box like that, how long would be the longest stick that could fit in that box? Huh? Well, I'm going to draw in some auxiliary lines here in a different color. Okay? So can I do this like that, like that? Look at me go. That's not so straight. Okay, so what you have to do here is, see this triangle right there? See that triangle? This, do you understand that this is a right triangle? Right there?
It doesn't look like one.
It is, because this is perpendicular to the bottom, right? And this here, this triangle here, is also a right triangle. See that? See that triangle?
This triangle is the right
The triangle on the bottom, right? This is a right angle right here, right? Even the
No,
triangle.
never mind.
And this is a right triangle too. So there's two triangles going on. See that?
But is it the triangle that like stops when the line hits it?
Yeah, there's this right triangle, and there's a right triangle on the
What
bottom.
color it in?
This triangle? Sure. Okay.
No, the other
Why
one.
are you good at color usually?
Look at that inside the line.
Yeah.
Oh. Okay, so there's this right triangle, and then there's this right triangle over here.
Goodness.
Okay?
How far is it?
Okay? Both of those are right triangles. Because this one here is perpendicular to, these sides are perpendicular, yes? And this is perpendicular to the base. Therefore, what's this side over here of this pink right triangle over here? What's that side? 6, okay? So what I have to do is apply the Pythagorean theorem twice, okay? So I would go 6 squared plus 8 squared equals
10 squared.
c squared, right? So 36 plus 64 equals c squared. So 100 equals c squared. So c equals 10.
I have a question.
What?
Of course, yeah.
But isn't that one a leg, not the hypotenuse?
It's the hypotenuse of this right triangle. It's a leg of this right triangle.
But wait, where's the right? Where's the right?
Pause now, okay? So this side is 10. Okay, so this is 10 over here. And how long is this side over here? 5. Okay? So now I want to find this side. We'll just call it D, right? D over there instead of C, because we already found one called C. So now in this right triangle, 5 squared plus 10 squared equals D squared equals D squared, okay? And that gives me 25 plus 100 equals D squared. And D squared equals 125. And D is equal to the square root of 125, which is about, Max tells us about 11.2 or something. Okay, so that's a good problem. We've got some real life applications. Maybe you want to send a back scratcher to your relative, and you want to know if that back scratcher will fit in your box, right? And so that's, it does have some application. Don't laugh. I got a back scratcher for Christmas, okay, and it's a really nice one. But, and I'm sure they had to figure out what size box to fit into, because my kid broke my other. So, anyway, then going backwards, just going back, so the converse of the Pythagorean theorem, okay? Hey, you're interrupting my nice music, my recording music. Converse of Pythagorean theorem which is on your conjecture sheet, which is, remember from your early in the semester, does anyone remember what a converse is?
The opposite?
What you get when you switch the hypothesis with the conclusion. So this says if a squared plus b squared is equal to c squared, then the triangle is a triangle is a right triangle.
Is that
Okay?
the first one?
That's the second conjecture of your sheet. So for example, you might be asked, do 6, 5, and 7 make a right triangle? Make the sides a right triangle. Okay, right triangle.
Wait, what do you mean do?
Do sides of 6, 5, 7. Do you get it now?
Yeah.
Okay. So what you have to do is check. Is 6 squared plus 5 squared equal to 7 squared? And you have to see 36 plus 25, is that equal to 49? And the answer to that is?
No.
61 is not equal to 49. So the answer is no. Okay? But if you saw something like 3, 4, 5, what would you say?
Yes.
Yes, because 3 squared plus 4. How about something like this? This one's a little bit trickier. How about root of 2 and root of 2 and 2? What do you think? So, root of 2, and 2. Let's see. Root of 2 squared plus root of 2 squared, is that equal to 2 squared? What's root of 2 squared? What happens when you square a square root? 2 plus 2
It does work.
is equal to 4. So, aha! Yes. Yes. So, that's a unique case. All right? And the